Okay, since these costs are based on the NGFS pathways to net zero to keep the global warming to below 1.5 degrees C by 2100 with the 67% probability, let's just run through what is involved in these scenarios, what are the various assumptions and so on. So net zero scenario 2050 scenario pathway from NGFS, National Network for Greening the Financial System. CO2 emissions in billion metric tons from various sectors: power, buildings, mobility, industry, agriculture, forestry, and other land use, AFOLU, and CO2 removal. So the emissions would have to ramp down, but at some point around 2030 we have to start drawing down CO2 to reach net zero by 2050. So there is a significant amount of drawdown required because the emissions will remain here, and methane emissions in million metric tons would also remain almost fixed for AFOLU here. But the supply of energy and end-use sectors have to drop, and net emissions have to drop by 2050. So the net zero has to consider the fact that non-CO2 greenhouse gases will also be part of the 1.5 degree scenario. So to meet them, we have to also include other non-CO2 greenhouse gases and not just focus on net zero, because net zero alone is not going to bring us the pathway to global warming target. Net zero is by itself a good target. That's what we are looking at, but we cannot forget the others. Energy use accounts for 83% of the CO2 emitted across energy and land use systems. CO2 emissions per fuel and energy and land use systems in 2089. So in power you have oil, natural gas, coal, and non-energy. So that's the percentages there. Industry, mobility, buildings, agriculture, and forestry contribute to the consumption of oil. Natural gas, coal has a significant fraction from the industry, so most of it is for power industry, and there is also some for buildings. Non-energy, so those are the percentages on this side as well. In addition to, so within 31% of the oil, here are the various percentages, and within coal you have the various percentages and so on. So in the non-energy sector emissions, you have also contributions from power, industry, mobility, and so on. So these are things that have to be kept in mind just in terms of accounting, so that net zero can track all of the sectors that are contributing and could be included in the pathways to net zero. Power and industry are major energy consumers and together generate about 60% of the CO2 emissions. So this is the share of emissions per energy and land use system in 2019. Carbon dioxide, power, industry, mobility, buildings, agriculture, and forestry here, and subsectors share of subsectors share of system emissions. I don't know why I'm fumbling these words, but anyway, power, electricity 97%, heat 3%. In industry, of course, steel and cement dominate, with oil and gas extraction right behind. Mobility, road dominates. Aviation is high, but per capita emission of the aviation tends to be disproportionately high. So public transportations on road can be much more economical in terms of per person emissions for the same distance traveled. Buildings, residential and commercial 70-30. Agriculture, farming and fishing, and forestry 100% in terms of the emissions from just the perturbations, deforestation, and other land uses like urbanization and so on. So methane has also contributions. Nitrous oxide also has power, industry, mobility, agriculture, forestry, and waste. So I'm just running through them so that you can get a sense of how much detail is involved in tracking the financial system and the emitters so that you can actually head towards greening the financial system. The NGFS Net Zero 2050 scenario entails a transformation of energy and land use systems. So this is the first of the two. Activity level trajectory 2020 to 2050. Overall primary energy exajoules. Mix has to be biofuels, renewables, nuclear, oil, gas, and coal. So coal has to disappear by about 2035 or so. Oil has to come down and still hasn't disappeared, and in fact is more than gas in this scenario. Nuclear is small here, renewables have a large chunk, and biofuels. We are not talking about all the other related issues of biofuels, how they interact with food security, land use, water use, what are the unintended consequences, and so on. Emission trajectory 2020-2050 for global CO2 emissions obviously has to drop off to zero by 2050. In the power sector, electricity generation by source in petawatt hours again has a mix: biomass, solar, geothermal, hydro, wind, nuclear, oil, gas, and coal. So electricity generation emission have to drop from the current level of about 14 billion metric tons to zero by about 2045 or so. Okay, these are the scenarios for 1.5 degrees C, so just remember that. Industry, steel production in billion metric tons, low emissions, so from scrap and hydrogen, low emissions, high emissions, so various combinations of things are included. Industrial processes and energy demand, CO2 emissions in billion metric tons have to drop off, obviously. Cement industry, low emissions, biomass kilns and fossil fuel kilns with carbon capture and sequestration, and high energy emissions fossil fuel kilns here as well. Let me pause here a minute and add. So, let's just continue. So here, just want to be sure to mention that this is electric arc furnace, direct reduced iron with electric arc furnace, basic oxygen furnace with carbon capture and sequestration, and so on. So those are the details that matter in terms of moving towards net zero. The NGFS Net Zero 2050 scenario 2 of 2, activity level trajectory again for mobility, battery electric vehicles and fuel cells have to basically take over the whole system by completely removing the internal combustion engines by 2050 for hitting net zero. And transportation CO2 emissions have to drop from the current level of close to 8 billion metric tons down to about 4. So obviously it's not going to go to zero there, but carbon removal has to make up for that. Buildings, total heating systems sold per year in millions. So you look at the time going from 2020 to 2050. So heat pumps have to take up a lot of the work. District heating still remains. Biomass boilers are a small percentage, but fossil fuel boilers have to be phased out by 2050 to bring the emissions from the buildings from about 2.5 billion metric tons in 2020 to about 500 million metric tons or so by 2050. Agriculture, again, looking at emissions in billion metric tons dry matter. So you have biomass, food crops and livestock that will increase in terms of the production. Agriculture, forestry and other land use referred to as AFOLU in IPCC reports has methane emissions that are expected to remain fixed because they are irreducible, and forestry and other land use on the other hand is expected to increase from about 4 billion hectares to 4.15 billion hectares or so, and then maybe remain fixed. So this under reduced emission from deforestation and reduced forest degradation or other forestation efforts, etc., have to work together here, and that has to be part of the commitment to methane reductions as well. So AFOLU CO2 emissions have to drop from about 4.5 billion metric tons in 2020 and maybe go negative at some point and then come back. So obviously these kind of calculations involve all kinds of assumptions, but let's keep that in mind. Looking again at the spending on physical assets that we looked at in terms of current spending and new spending per year required for a total of $9.2 trillion per year, heading to the net zero scenario for a total of 275 trillion or so. What are the details there? So if you look at time periods 2021 to 25 and 2046 to 2050 with 5-year period of estimates, you have in 2020 level 6 some percent. So we are looking here at annual spend on physical assets for energy and land use systems in trillions per year. So this is the mix involved here: hydrogen and biofuels and heat. So you can see mobility is a big part here, but you also have agriculture, industry, forestry, fossil fuels, buildings, power that we looked at before. Tracking those, you can see that mobility increases over this period and others adjust up and down. So the NGFS Net Zero 2050 scenario requires a total of 275 trillion in spending over this period from 2021 to 2050. Already we're in 2022. Obviously this is already a bit behind. The current policy scenarios would obviously result in a little bit less in spending, but obviously the 1.5 degree scenario is not going to be met in the current policy scenario. So with the current policy scenario, the question is how much warming are we going to reach above the 1.5 degrees C, or are we even going to go beyond 2 degrees C and so on. So this is talking about 1.5 degrees C target for 2100. So global average delivered cost of electricity in the net zero 2050 scenario would rise in the short run and then fall back from its peak. So the costs include generation operating costs, additional grid costs which will rise significantly to about 2030 and then drop off. So here is the total cost in 2100. So this is in again delivered cost of electricity in dollars per megawatt hour indexed to 2020, and this is the 2050 scenario and how we will end up in 2100 with those scenarios. The net zero 2050 scenario, about 200 million direct and indirect jobs would be gained and 185 million lost by 2050, with the baseline of 2020 being at 896 million jobs, direct and indirect. So total job shifts, direct and indirect, by 2050 would be impact of growth in population, income and productivity, removing 114, so a loss, and net impact, impact of net zero shifts would be 202 gains and 187 loss, and net zero 2050 would be a total of 797 million losses here. Okay, so those are, you can think of those as shifts. Okay, so you can think of job gains and job losses also in terms of agricultural fields, auto, power, hydrogen, oil and gas, other, and capital expenditure jobs and so on. So I'm just again running through this to give you a sense of how many things are involved in accomplishing net zero according to the NGFS scenarios, what it would cost and what it would bring. Okay, so countries with lower GDP per capita and fossil fuel resource producers have higher transition exposure, as we said before. So at 0 we have no exposure, so nobody has 0. At 100 we are fully exposed, so the scale runs from 15 to 60 here as a index of exposure, and GDP per capita in thousands goes from 1 to 90, and as we said before, countries like France and US are down here in low exposure and high GDP per capita. Then you have transition to UK, Germany, Canada, Spain, South Korea, UAE, and Qatar have, for example, high GDP but high exposure because they are fossil fuel countries. And you have China, which is growing and highly exposed. India is much worse off with lower per capita GDP, higher exposure, and Pakistan is up here in the corner as the most exposed, poorest country. Bangladesh is here as well, Nigeria, Kenya, Indonesia, so you can see the range of countries. And the archetype of physical risk include significantly hotter and more humid, hotter and more humid, hotter, the color scales, increased water stress, diverse climate, including extreme events, and there are lower risks here. The circle size corresponds to population as we saw before. Okay, so China and India up there. Without going into too many more details, these are the goods traded internationally which represent significant cross-border flows embedded in CO2 emissions. In 2021, China to US was a huge part of the embodied carbon in trade, but US also deals with Mexico, Canada, back and forth, and you have China with most other countries in the world, including with Japan, South Korea, Thailand, India, and so on, and they are all entangled together. So costing and accounting carbon is going to be tricky as well. Countries could capture potential growth opportunities from the transition to net zero emissions. This is looking at renewable power example for average theoretical solar potential in kilowatt hour per square meter per day, going from less than 2 to greater than 6.4. So you can see that this part of Africa has a very high theoretical solar potential. Also over here in the Namib Desert, high up here in the Andes, southwest US, parts of Australia, part of Tibet, and Middle East and Central Asia, and India as well. Mean wind power density of 10%, windiest areas at 100 kilometer height, going from less than 25 watt per square meter to greater than 1300 watt per square meter. You can see that there is very little wind potential in large parts, but there are parts where the wind potential is high. So here solar potential is low, but wind potential is high. Wind potential high here, but solar potential almost zero. India has a good solar potential, but not so much a wind potential, and some places have both wind and solar. So here you have wind and solar potential. So will that help turn Sahara into a green region again? Well, we have to see. Of course, these also include must also consider costs of moving the energy grids, new grids, and so on and so forth. Based on the nature of their exposure to net zero, to the net zero transition, countries can be grouped into 6 archetypes. So they go from transition exposure low to high, and the transition exposure score, country with archetypes, and various other emitters in core operations, ranging again from producers of fossil fuel energy, fossil fuel dependent products, power industry, mobility, and so on. I won't go through all that, but just look at the transition exposure archetypes. Fossil fuel resource producers, emissions intensive producers, agriculture based economies, land use intensive countries. Brazil shows up here, which is doing very poorly in managing Amazon forest under Bolsonaro. Downstream emissions manufacturers, and services based economies. So various countries fit into these with various emitters of core operations and various exposure scores here. So the area exposed most relevant to the archetype is indicated by the rectangles, but it gives you an idea of just how detailed the transition is going to be and how many factors have to be considered and how many disparities in different regions, different economies, different population centers, and different exposures have to be considered. So managing the transition of the entire planet to net zero is going to be a monumental challenge. So there is the issue of whether we have the technology to do it, and then there is the issue of what it would cost, and then finally what it would bring, and how people would view these upfront investments for the future with all the discounting that goes on, and which depends again on the value people put on the future of the environment for their children and for the posterity as a whole, right? So let's leave it there.